promised we would talk a little bit more about Git and about version control in general. Who has never used any kind of version control system before, whether it's Git or Subversion or something else ancient? Is there anybody who hasn't used version control at all? Okay. So why do we do it? It sounds nice, but what does it actually get us? I take backups. I don't need version control. I'm never going to lose my stuff. Well, what if I spend 7 hours coding something and I realize that about 3 hours ago, I made a design decision basically that took it in one direction, and I realized 3 hours later that that was the wrong direction. And now I could wish I could go back to that earlier state and keep working from there. But I don't know that I remember everything I changed since then. Well, if I'd been using version control, even though I'm on a team by myself, I wouldn't have that problem. I could always rewind to a previous commit. So it's good even if you're working on a team by yourself, and even if you take backups. Backups do not help you get to a previous version. Or at best, they only get you to a previous version maybe once a day. And it's a big pain in the neck to restore from backup, but it's very easy to rewind the clock with Git. Let's say I just released something into production, and 5 minutes later, I get a panicked phone call from the operations center saying something broke. I was adding this new feature, but some other older feature broke because of this change, and I can't immediately identify why. But meanwhile, they're down. They're in big trouble. I need to fix that. I can't just undo all my changes one at a time to try to get back to the working state. I may very well not fix the problem along the way, and it may take a while to diagnose the problem. So it would sure be nice if I could just roll back production to a previous version. Again, version control to the rescue, even if you're on a team by yourself. Now, if you are working for with other people and you don't do version control, you are in a world of pain. Maybe that's self-explanatory, but if you're both changing the same files, you're just going to break each other's stuff nonstop. And besides, it's nice to be able to go back in time and just look at what you did. Look at the log, git log. Here we go. Update the heading with a value from the form, declare the function with const. I can see all of the previous steps and when I did them, what date, what time. I'll hit Q to get out of this. When you look on GitHub, it's even more obvious, the benefit. So not only, let's see, is this the one? This is not, this is the morning class. Let's look at our commits. So change the button text when clicked. Not only can I see that text, but I can also see exactly how I did it. I removed these 3 lines and added these 2 lines. And that's all I did to do that. And it's very easy to go back and see that. And furthermore, if there's some line in some file, I have no idea why it was ever added. It doesn't appear to be doing anything. You can always find which commit that thing came from using a command called git blame. And you can understand why it was added and maybe discover its actual purpose and determine whether it's still doing anything or whether that's obsolete at this point and it can be safely removed. So always a good idea to commit early and often. Every time you make something work, commit. If you're writing a feature that takes a week, don't just commit once at the end of the week, for heaven's sake. Commit every time you make a little baby step and things still work. Don't commit things in a broken state unless you really, really need to. So that's the point. The way things work in Git is a distributed version control system, which means that everybody has a copy of the entire repository. You have all previous versions on your laptop. They're not just sitting on GitHub. They're also in your copy. You have the entire thing. In fact, you don't even have to have a remote like GitHub. You can just do the whole thing on your laptop. Now, in another scenario, let's say you're teaching a coding boot camp and you're on a stage that's about that tall and your desk falls off the stage. And let's say it falls in such a way that your laptop falls first and the desk lands on top of your laptop and the Apple Store closes in a half an hour, and you make a quick phone call to a guy you barely know and say, hey, Seth, can you give me your employee discount real quick? He says, sure. Run to the Apple Store, run back, keep teaching. I was able to keep teaching. Hypothetical teacher was able to keep teaching. Why? Because everything I had been doing in class right up to that minute was already on GitHub, because I'd been not only committing but also pushing along the way. So we were up and running in no time. So, a very good thing. But you do have the entire repository on your machine. Sometimes this thing does not want to, Apple TV does not want to update when I change my screen too fast. This is one of those times. Let's see what we get right now if I type git status. It says nothing to commit, working tree clean. What the heck is the working tree? The working tree contains the changes you've made since your last commit. But it really doesn't want to refresh that. You jerk. So if we make a change, let's make a change. Let's create a README. We'll use touch, README, all caps, .md. What's MD stand for? Anybody know? Markdown. A nice plain text format that translates nicely into HTML, but is very readable in its raw format. So let's make ourselves a README. And we'll just begin it with hash space user directory. That's how you do a heading, an H1 in Markdown. 2 hashes would be an H2. And that does break up the text very nicely, so it's actually a pretty decent way in a plain text file to do a heading. So let's see what git status gets me now. Now I have an untracked file, readme.md. So there is something in my working copy that is not in my repository. Is this working now? Dang you right to heck, you cussing cusser. Oh, there it is. Now that it's not on my screen anymore. Oh, kidding me. Let's give it a second to catch up. You can do it. I believe in you, Apple TV. I do not believe in Apple TV. I got this lovely diagram. Let's just open the diagram in preview and drag it onto my screen. If I can find the dang thing. Oh boy, can I find it? Yes, this. So, working directory. All the changes you've made since your last commit. If I try to commit right now, what's it going to say? What error message am I going to get? Git commit. Add readme. Nothing added to commit, but untracked files present. So that didn't do a darn thing. It doesn't know about that change yet. It's living in my working directory. Before it can get to my actual repository, it has to be staged. It has to be added to Git's index. So to go from the working directory to the index, I use the command git add. So let's do it. Git add readme.md, or as we know, git add dot to add all changes from the working copy. Now if I do a git status, I see changes to be committed. So if I type commit now, this will be there. And it says use git reset head to unstage. So what we've done with git add is move it from the working copy to the index or the staging area. It is staged for commit now. Git is paying attention to it, but it is not yet permanently in our repository. We've not yet labeled it. So we use git commit and give it a nice message. Add readme. And now, with git add, we went from the working directory to the index or staging area. And from there, with commit to the actual repository. Now it's there. Now it's got a label on it. But this is still all happening on my laptop, right? When we first synced it up with GitHub, we copied 2 commands from the web, you may remember. The first one was get remote add. We said get remote add origin and then the URL of our repository. So get remote add, as you might guess, adds a remote. So remotes are just other machines that have your repository on them that you want to sync with. They're no more the source of truth than your own laptop is, but we often treat them that way. So GitHub is like the master copy of my thing. And we just named the remote origin when we said get remote add origin. But origin is what people usually use if they have something that they kind of consider their source of truth. And once that remote is there, then we can use the commands push and pull to put things in the remote and to pull things from the remote. So the second command we copied was get push -u origin master. Origin master told it which remote we want to push to. Master told us which branch on the remote. The -u said, I want to use this remote and this branch from now on. So I just want to say get push without saying all that nonsense. So now I can just say get push, and it has gone from my local copy of the repository to GitHub's copy. So I'm going to refer to this diagram the next several times that we commit to kind of drill in the whole process. When you say add, you're moving it from the working copy to the staging area where it can be committed. And when we say commit, it's permanently in the repository with a label attached. And when we say push, it's on the remote. Now pull would take a commit that is on the remote that you don't have yet and pull it to your machine. That would happen a lot if you have other people who are working on the same code base, or if you're working on the same code base for more than one machine. Questions? Cool? All right.